On behalf of ROHINI College of Engineering and Technology, myself, Justin Leo, Assistant Professor of Mechanical Engineering Department, welcome you all for this Unconventional Machining Process course. And the course code is ME8073, and this is a professional elective 2 subject for the mechanical engineering students of Regulation 2017. So here in this video session, we'll be studying the second unit of unconventional machining process, that is thermal and electrical energy based processes. So in this we'll be studying about introduction to thermal energy based processes. So the objective of studying this course is to learn about various unconventional machining processes, the various process parameters and their influence on performance and their applications. And the syllabus for the second unit, that is thermal and electrical energy based processes, is the electrical discharge machining, wire cut electrical discharge machining, and we'll be studying the working principle, equipments, process parameters, and the surface finish and the electrode tool, power and control circuits, tool wear, and about the dielectric flushing and applications, and laser beam machining that comes under this electrical energy based processes, and drilling, plasma arc machining, and electron beam machining and its principles, equipments, and stripes, beam control techniques and its applications. So these are all the textbooks and reference books for this unconventional machining process course. And the unconventional machining process course code ME8073, the course outcomes are: upon completion of this course, the students will be able to explain the need for unconventional machining process and its classification from the first unit. And the students will be able to compare various thermal energy and electrical energy based unconventional machining process from the second unit. And the students, upon completion of this course, will be able to summarize various chemical and electrochemical energy based unconventional machining process from the third unit. And the students will be able to explain various nano abrasive based unconventional machining process from the fourth unit. And the students will be able to distinguish various trends based unconventional machining process after studying the fifth unit. So introduction to thermal and electrical energy based process. So in this introduction to thermal energy based process, in thermal energy based process, normally heat energy is made to concentrate on a small area of the workpiece to melt and vaporize the tiny bits of work material. The required shape may be obtained by the continued repetition of this process. So in this electron beam, in this thermal energy based process, you'll be studying about this electron beam machining, EBM, laser beam machining, LBM, plasma arc machining, PAM. So coming to the electron beam machining process. So in electron beam machining, high velocity focus beam of electrons, you can see from this figure, you have an electron gun, and high velocity beam of electrons is used to remove the metal from the workpiece. So these electrons would travel at half the velocity of the light, that is 1.6 into 108 meter per second. And this process is best suited for micro cutting of materials. So coming to the principle, so when a high velocity beam of electrons from the electron gun strikes the workpiece, its kinetic energy is converted into heat energy, and this concentrated heat rises the temperature of the workpiece here, and vaporizes a small amount of it, resulting in the removal of material from the workpiece. So this is the principle, and here you can see the electron beam machine setup. So electron beam process, you have two types. That is thermal energy based process, is that's electron beam machining. So machining inside the vacuum chamber and machining outside the vacuum chamber. And advantages of electron beam machining process, and it has the following advantages. So it is an excellent process for micro finishing, and very small holes can be machined in any type of materials to high accuracy, and you can machine different sizes and shapes of holes, and no mechanical contact between the tool and workpiece. So that is the main good advantage. And the process is very quick. Harder material can be machined at a faster rate than the conventional machining. And you can machine even the electrical conducting materials, and the physical and metallurgical damage to the workpiece are very less. And the automation of this process is easy, and extremely close tolerances are obtained. And you can machine brittle and fragile materials. So the disadvantages of electron beam welding process. So metal removal rate is very slow, and the equipment, the cost is very high. Large workpieces can't be machined here. And to operate the machine, you require high skilled operators. High specific energy consumption is required. And a little taper will be produced on the holes. And the vacuum requirement would limit the size of the workpiece, and only thin materials can be applicable. And the spot where the electron beam strikes the material, a small amount of recasting and metal splash can occur on the surface. So it has to be removed afterwards by abrasive cleaning. It is not suitable for producing perfectly cylindrical deep holes. So coming to the introduction to thermal energy based processes, here we will be studying now about the second process, that is laser beam machining. And this is a thermal machining process which uses a laser beam to produce heat and removal of material from the workpiece. And here the metal is removed from the workpiece by melting and vaporizing of the metal particles in a controlled manner on the surface using heat produced from the laser. And this is widely used in cutting sheet and drilling holes. So it is a non-conventional machining process in which tools are used. And this laser machining is widely used in cutting and drilling operations, and both metallic and non-metallic workpieces can be machined using this machining process. So the principle of laser beam machining. So here the basic principle involved here is the laser. So here you can see a laser beam is made to focus on the workpiece through the lens. In this machining process, a laser beam is used, which is a monochromatic high intense light, and this can cut a metal, any metal and non-metal. And this machining can be used to cut and remove material, even the hardest material present, which is diamond. So this is a machine setup, and you have a reflecting mirror, and you have the flash lamps and the ruby crystals, and the laser light beams is made to focus on the lens, and the laser beam which strikes on the workpiece would melt the metal, and the metal is removed. So applications of laser beam machining. So laser can be used in wide range of manufacturing applications. So material removal, drilling, cutting, and welding, cladding, alloying, and this laser drilling, the laser beam is focused over the desired spot size, and the laser beam machining is used for thin sheets. Pulse laser can be used, and for thicker one, continuous laser may be used. So the advantages of laser beam machining is it can be used to cut any material, and no tool cost because no physical tool is required, and no cost for maintenance and replacement of tools, and no delamination is cost since no physical contact with the workpiece, and easily automated and flexible. Complex shapes of different sizes can be machined as laser can be moved in any path. A good surface finish is obtained, and you can drill micro holes in workpiece with high accuracy. So the disadvantages of laser beam machining is it's very high capital and maintenance costs. It cannot be used to produce blind hole. It can lead to safety hazards. And the last one is in this thermal energy based process, introduction to plasma arc machining. Here, the plasma arc machining is used to remove material from the workpiece. So in this process, a high velocity jet of high temperature gas is made to melt and remove material from the workpiece. And this high velocity hot gas is nothing but is called as a plasma jet. So when a gas or air is heated to a temperature of more than 5000 degrees Celsius, it will start getting ionized into positive ions, negative ions, and neutral ions. So when the gases or air is ionized, the temperature reaches from 11,000 degrees Celsius to 28,000 degrees Celsius. And this ionized gas is called plasma. So the gas or air is heated with arc, and this plasma produced by heating gas can be used to remove the material from the workpiece. And hence this process is called plasma arc machining. So this is a diagram, the machine setup. So high velocity of high temperature air is used to remove the material from the workpiece by melting it. And here the gas used is the plasma gas, and the gas used in plasma arc machining is chosen according to the metal which is used as a workpiece. So the principle of plasma arc machining. So normally this plasma arc machining uses ionized plasma to transfer heat, and this plasma is obtained by forcing gas through an electric arc generated between cathode and the anode. And this high temperature plasma melt the metals and remove the material from the workpieces. So coming to the advantages of plasma arc machining, as hard as well as brittle metals can be machined easily with this process, and faster production rate is obtained. Small cavities can be machined using the process with good dimensional accuracy. Rough turning of very hard materials can be done and used in machines that are used to repair jet engine blades. And disadvantages of plasma arc machining is the equipment used in plasma arc machining are very costly, and the metallurgical changes may take place on the surface of the workpiece. Inert gas consumption is high, and due to oxidation and scale formation, shielding is required. And the application of plasma arc welding, it is used in mill application, used in nuclear submarine pipe system, used in welding rocket motor case, used in welding of stainless steel tubes, is used for profile cutting. So with this we come to an end with this introduction part of this second unit. So thank you and have a great day.